In the modern world, copper is a true protagonist. It is present in our cell phones, electric cars, the pipes in our homes, and the vast electrical networks that power entire cities. Its versatility, conductivity, and strength make it one of the most essential metals for our society. But have you ever wondered where it comes from? The journey of copper is a true story of engineering, geology, and chemistry. A saga that begins deep within the earth and ends in the products we use every day. Let's dive into this fascinating world to discover how raw rock is transformed into a priceless metal. Copper is one of the best conductors of heat and electricity. It offers exceptional resistance to corrosion. Extremely flexible and malleable, it can be recycled indefinitely without losing its properties. It is found in the Earth's crust, specifically in the surface layers composed mainly of sedimentary rocks. Its extraction is a complex process that involves several stages. The first involves identifying areas with high potential for copper or deposits. This requires geological surveys, sample analysis, and the use of prospecting techniques to locate economically exploitable deposits. Once a deposit is discovered, everything must be prepared for extraction. But before accessing the valuable minerals, huge layers of waste material must be removed. In some areas, the mineral deposit can reach depths of up to 100 m, requiring the use of colossal machinery and tons of explosives. To extract the rock containing the copper, gigantic drills are used, capable of drilling around 130 holes, called blast holes, at least 16 m deep, the height of a 5-story building. A powerful mixture of ammonium nitrate and fuel is introduced into each hole, supplemented by a certain quantity of a high-energy explosive called AMPHO. Once everything is inserted, the hole is plugged with sterile material. From a secure area, an operator triggers the charges, causing a series of perfectly timed explosions. Each detonation is so powerful it could bring down an entire building. The interval between two detonations is barely 2 milliseconds. This detonation pattern was specifically designed to fragment as much copper-bearing rock as possible while minimizing material dispersion and excessive dust formation. Once the rock is fragmented, the ore loading process begins. Huge machines lift the blocks of rock with their gigantic buckets and dump them into enormous mining haul trucks. To obtain a single ton of pure copper, nearly 200 tons of ore must be extracted. Hydraulic excavators can lift up to 80 tons of rock at a time. Yet this rock typically contains less than 0.5% copper. The trucks, nearly 7 meters high, are capable of carrying up to 400 tons of load. Because open-pit mines cover such vast areas, their operations are monitored and managed from a control center similar to an airport control tower, where engineers can observe all ground operations in real time. But how does this raw rock transform into one of the world's most widely used metals? The release of copper depends on the nature of the ore. Depending on whether it is oxidized or sulfidic, the processes differ. In the case of oxidized ores, the extracted rocks are stacked in special areas called leaching areas. They're continuously sprayed with a dilute sulfuric acid solution. Over several weeks, this solution slowly seeps through the rocks, gradually dissolving the copper they contain. The liquid, loaded with copper ions, is then collected in basins and transported to the processing plant. In special channels, the copper solution comes into contact with an organic reagent that allows it to float on the surface. Next, an acid solution is added, which increases the concentration of copper and makes it electrically conductive. This liquid is then transferred to a series of large tanks containing thin copper plates called cathodes. Once an electric current is applied, copper ions gradually begin to deposit on the cathodes. In just 10 days, each plate reaches a thickness of about 2.5 centimeters. At this stage, the purity of the copper is close to 100%, which is essential for its use in the manufacture of electrical products. Extraction from sulfide ores, on the other hand, is much more complex. It all begins in a gigantic drum called a crusher. Inside, huge steel balls grind the wet rocks into smaller fragments. The crushed material then passes over a perforated belt that lets the fine pieces pass through, while the larger pieces are returned to the crusher for another cycle. Once the rock is ground into powder, chemicals are added to coat the copper particles, along with a frothing agent. This mineral slurry is then sent to flotation tanks, where air bubbles carry the copper particles to the surface. This copper-rich froth is collected and filtered to produce a concentrate with a purity of at least 30%. The next step takes place in the smelting plant. The concentrate is transported by train to huge deposits where it is mixed in layers with silica sand called flux, which helps remove impurities during smelting. Subjected to extreme temperatures, the charge transforms into a molten liquid. The slag, made up of iron and other minerals, floats to the surface while the copper accumulates at the bottom. At this stage, its purity reaches approximately 60%. It then passes into a second furnace where its purity level rises to 98%. The molten residue is removed and solidifies, forming incandescent streams that resemble lava. Meanwhile, cranes transfer the liquid copper to another furnace for the final purification stage. The purity then rises to 99%, and the molten copper is poured into large molds to form massive rectangular plates called anodes. These plates are cooled by water jets, solidified, and then ejected by hydraulic cylinders. They are then cleaned to remove mold release agent residue and transported to a refinery, sometimes hundreds of kilometers away. In the refinery, purity reaches its maximum. The anodes are immersed in large tanks containing an electrolytic solution and placed opposite thin metal strips called cathodes. When an electric current is applied, pure copper transfers from the anodes to the cathodes while impurities fall to the bottom of the tank. The result is copper of near-perfect purity, ready for use in the most demanding electrical applications. The refined copper is then introduced into a vertical furnace where it is remelted. The molten metal is directed into a mold that produces large rectangular blocks approximately 6 m long. Upon exiting the mold, the copper is cooled by jets of water and takes the form of a continuous bar. This bar then passes between several rollers that reduce its diameter. At the exit, it is transformed into a copper wire approximately 7 millimeters thick. This wire is spirally wound by a machine and then compressed to take up less space during transport. These immense coils of pure copper are then ready to be transformed into conductive wires capable of carrying electricity to the four corners of the world. And this is the incredible journey of copper from raw rock to the electrical conductor that powers our modern lives. But beware, that's not all. The rest of this video will be just as exciting, so stay tuned until the end. And most importantly, don't forget to like, subscribe, and hit the bell so you don't miss any of our upcoming content.
Imagine a world where every piece of waste can become a valuable resource. Every year, the planet produces more than 108 million cubic meters of particle boards, made from recycling 16 million tons of wood waste that could have rotted in landfills or been burned. It's not just a material, it's a recycling revolution. Old packaging, wood scraps, and even worn-out furniture are reborn to become the solid foundations of our kitchens, our tables, and our shelves. And did you know that 25% of this production is already certified as ecological and environmentally friendly? In this video, we will unveil the secrets of this industrial achievement. From giant shredders swallowing entire logs to heated presses where resin transforms chips into a monolithic block, discover how waste comes back to life in the perfect structural sandwich of a panel. It's much more than wood, it's the future of sustainable design. Are you ready to follow this journey from waste to masterpiece? Then stay tuned, because every step will amaze you. It all begins in a vast raw material storage yard, a place where the foundations of future panels constantly converge. Here, the idea of rational resource use comes to life on an impressive scale. Contrary to popular belief, high-quality commercial wood is almost never used in panel manufacturing. The philosophy is to give a second life to wood waste, transforming what was once seen as a byproduct into a valuable material. Mountains of raw material, several meters high, pile up here. The basis of this process is technological chips from low-quality wood, unusable for sawing. A large share comes from sawmills, slabs, the rounded parts of logs, plank cutoffs, and thin strips from cutting. Carpentry and furniture factories also supply planing and milling waste, chips, and sawdust. A major flow comes from secondary wood, pallets, crates, packaging, and even used furniture gain a new life after rigorous cleaning. Each batch of material undergoes strict control upon arrival. Purity is the key to quality, and the first step is to remove all metallic inclusions. Powerful electromagnetic separators capture nails, staples, or bolts that could damage the shredders. Then, screening systems eliminate mineral impurities, sand, stones, and other abrasive debris. When entire logs several meters long are used, they pass through a debarca or a rotating drum that removes their bark. This step is essential, since bark weakens the binder quality, compromises the product, and spoils its appearance. Once prepared, the cleaned wood begins its journey on long conveyors. It disappears into the mouth of a giant shredder, a monstrous machine capable of swallowing wood pieces several feet thick. Inside, sharp knives spinning at thousands of revolutions per minute reduce the wood into uniform chips. These chips, although regular, are still only a semi-finished product. Their cubic structure does not allow the creation of a dense and solid panel. A finer secondary grinding is necessary, performed in precision machines called flakers. This is where the true particle is born, the one that will give its name to the panel. The geometry of the chips becomes crucial, as it must be engineered with precision. For the outer layers, responsible for the smooth surface, fine flat flakes are produced. They look like flakes only a few hundredths of a millimeter thick. Their large surface adheres perfectly to resin, creating a finish ready for lamination. By contrast, the core layer uses thicker particles that form the resistant skeleton of the panel. They give it rigidity, the ability to resist bending, and to hold fasteners such as screws and bolts. But before assembly, the chips have variable moisture content, unacceptable for quality bonding. They therefore pass through enormous rotary dryers filled with hot air. Automated control ensures a strict moisture level, between 2 and 6%. Excessive drying prevents proper glue absorption. Too much moisture would cause internal cracks during pressing. After drying, the chips are sorted by size and weight.
The large ones fit the inélayé, the fine ones form the outélayé.
This is where the binder comes in, mainly synthetic resins such as urea formaldehyde or melamine. The chips go into continuous mixers where the resin is sprayed in a sticky mist. Each particle is coated, ready to bond with the others. The quantity is crucial, varying between 6 and 10% of dry weight. Other additives can be added to improve strength or reduce flammability. The sticky chips are then deposited on a conveyor by a forming machine. This is where the chip mat is born, organized into 3 layers.
The fine bottom layé, the thick central layé, then a fine top layé.
This sandwich structure guarantees strength and perfect finish. A pre-press compacts the mat, removing air and preparing it for transfer to the main press.
This is the part of the process, hot pressing.
In continuous or multi-opening presses, pressure of several dozen kilos per square centimeter compresses the chips. At the same time, the heat of plates at 200 degrees Celsius triggers the resin polymerization. In just a few minutes, the soft mat becomes a solid monolithic panel. These burning panels are then slowly cooled in step coolers. Controlled cooling prevents deformations or internal stresses. The panels then go through calibration and sanding, giving them precise thickness and a smooth surface. Finally, they are cut to standard formats and subjected to rigorous quality control. Only panels meeting density, strength, and dimensional accuracy standards are marketed. They are then sent to furniture factories where they become those everyday objects we use without even thinking about it. Each panel is proof that even waste can become the foundation of our modern comfort. And now one essential thing: if you enjoyed this dive into the heart of sustainable innovation, make sure to subscribe and hit the bell so you won't miss the next explorations. Your support is what brings ever more immersive content to life. Kit Kat, the crispy and chocolatey treat with a familiar and delicious taste, is loved by millions of people around the world. Beneath its iconic red wrapper lies a fascinating and meticulous production process. Have you ever wondered what makes Kit Kats so irresistible and appealing? Today, join us to discover the surprising journey of Kit Kat production inside one of the largest chocolate factories in the world. Every day, more than 8 million bars are produced there. This sweet adventure is sure to leave you amazed. The journey of cocoa beans from West Africa to the exquisite flavor of Kit Kat chocolate begins in the distant lands of West Africa. Vast cocoa fields stretch beneath the blazing tropical sun. In July, when ripe cocoa pods glisten in the heat, farmers begin the harvest season. They carefully pick each pod to preserve the precious beans inside. Every movement reflects their respect and pride in the fruits of their labor. Once harvested, the pods are opened to reveal the much sought-after cocoa beans. Each bean, embodying the essence of nature, is handled with care and laid out on large drying mats under the scorching tropical sun. These beans dry naturally for about 8 days. Over time, they lose moisture, their shells harden, and they lock in the exceptional chocolate flavor. The cocoa beans then undergo strict quality inspection before entering the production factory. They are first tested for moisture to ensure optimal drying and avoid mold. Their size and texture are carefully examined, and underdeveloped beans are removed. Finally, an experienced team conducts an aroma test to make sure each bean releases its unique fragrance. Inside the state-of-the-art factory, the beans undergo a 3-hour transformation process. The journey begins with meticulous cleaning. Workers pour the beans into massive conveyors that carry them to a cleaning station. In a specially designed rotating drum, the beans roll and rub against each other. Their shells loosen while powerful air jets blow away dust and impurities. The beans emerge spotless and ready for the next step. They are then roasted, where their hidden aromas awaken. Each batch is placed into a large roasting machine similar to those used for coffee. Cocoa roasting requires extremely precise control of temperature and time. This step represents the secret of master chocolatiers, as even the slightest variation can completely change the flavor. After enduring this heat, the beans, now rich in aroma, move on to grinding. They are crushed in a giant grinder, releasing their deep and intense flavor. As they break down, the beans gradually transform into a thick, smooth cocoa paste. This paste is then hydraulically pressed to extract cocoa butter, leaving behind large round cocoa cakes weighing about 7 kilograms each. These cakes, packed with a powerful fragrance, embody the very essence of cocoa. They are ground again into a fine powder, ready to create Kit Kat's unique taste. The cocoa powder is blended with sugar, milk powder, pure cocoa butter, emulsifiers, and other secret ingredients. The exact proportions form Nestlé's strictly guarded recipe. The mixture churns continuously in a gigantic machine until it becomes a thick, velvety chocolate mass. Next comes the art of conching, which refines the chocolate particles to a microscopic size. This ensures the chocolate melts instantly on the tongue. The longer the conching, the creamier and silkier the texture becomes. Finally, the liquid chocolate undergoes tempering. Its temperature is carefully raised and lowered to ensure it melts completely, then cooled to about 27 degrees Celsius. This process prevents unwanted crystals from forming and keeps the chocolate shiny and irresistible. If chocolate is the soul of Kit Kat, then the crispy wafers are its heart. Their meticulous creation begins with refined wheat flour, purified water, sugar, vegetable fats, and a pinch of salt. But the secret lies in a leavening agent that gives the wafers their light, airy texture. All ingredients are mixed in a massive blender until a thick, uniform batter forms. The batter is then poured into rectangular molds using ultra-precise nozzles, ensuring each mold receives exactly the right amount. The molds are heated at 175 to 200 degrees Celsius for 30 seconds. This intense heat bakes the wafers and gives them their signature crispiness. The wafers are then transferred to a cooling area, where gentle air currents gradually reduce their temperature. This step is essential to preserve their crunch and prevent the chocolate from melting during coating. While the wafers cool, the chocolate filling between the layers is prepared. Unlike the outer coating, this filling contains powder from recycled Kit Kats. Defective bars are finely ground and added to the creamy filling. It is smoother, resembling a chocolate cream, and helps bond the wafer layers without breaking them. The outer coating, in contrast, is thicker and firmer to give structure and protection to the bar. Then comes the most enchanting transformation, when the crispy wafers are covered in a stream of liquid chocolate. They travel along a conveyor under a delicate flow of glossy chocolate. 3 precise layers are applied to ensure each wafer is perfectly coated. Finally, a last wafer layer is placed on top like the finishing touch of the KitKat masterpiece. The journey continues on a modern conveyor, where sharp blades await. Each KitKat gently glides toward the cutting zone, where the blades slice them into perfectly equal portions. In an instant, complete KitKats appear, aligned and ready for the next stage. After nearly 15 hours of preparation, the smooth chocolate finally takes its familiar KitKat form. Ultra-fast machines fill hundreds of molds every minute, producing over 200,000 bars per day. Streams of molten chocolate are poured into molds to form the shiny, irresistible outer shell. Then the crispy wafers pass under a chocolate cascade that coats them evenly. This fascinating sight releases a tempting aroma of melted chocolate combined with wafer crunch, a true sensory delight that makes you want to bite into a freshly made KitKat straight from the production line. You surely know the legendary slogan, "Have a break, have a KitKat," a simple and memorable phrase with extraordinary marketing power. Since 1958, this slogan has become inseparable from the image of the crispy, chocolatey KitKat. Have a break invites relaxation, rest, and pause. Have a KitKat offers a sweet moment that delights the taste buds and brings back a smile. This clever combination of break and KitKat not only refers to snapping the bar but also to the universal need for a pause. This successful slogan played a crucial role in building KitKat's global reputation and is now considered one of the greatest advertising slogans of all time. Before reaching consumers and supermarket shelves, KitKat bars undergo strict quality checks. The slightest imperfection, such as air bubbles or cracks, results in immediate rejection. But these bars are not wasted, they are recycled into the inner filling. Perfect bars continue toward the automated packaging line, where rapid robotic arms wrap each bar in shiny foil, then add the eye-catching red wrapper. And so, KitKats are ready to reach consumers. Every day, up to 8 million KitKats leave the factory. They are transported to huge warehouses and distributed worldwide. Loaded onto trucks, KitKats begin their journey to bring chocolatey delight to people everywhere. If you find this journey captivating and want to discover more fascinating secrets of food production, subscribe to the channel and activate notifications so you don't miss any videos.